Good morning students, I am your maths teacher. In the last class, we learned the set operations. Today in this class, we are going to learn the properties of set operation. Before diving into the properties, let me recall the set operations what we studied in the last class. Union, intersection and complement of sets. Let's consider two sets. Let A is equal to 1, 2, 3, 4, 5 and set B is equal to 3, 5, 7, 10 and set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Then A union B, first operation A union B is equal to 1, 2, 3, 4, 5, 7 and 10. Which are the elements of set either A or set B or in both? Here let's not have the elements 6, 8, 9 which are in the universal set, since these numbers are not in either of these sets. So next, this is the graphical representation of A union B, which are 1, 2, 4, 5, 3, 7, 10. Here next the intersection part. Here the intersection is the common element between A and B. Here the common element between A and B is 3 and 5. See the diagrammatic representation of intersection of sets. The dark area is the intersection part of these two sets. Let's check what is complement of sets. Complement of set A is the element from universal set which are not a part of A. This is the complement of set A with respect to the universal set U. Here 6, 7, 8, 9, 10 are the elements which are in the universal set and which are not in the set A. So 6, 7, 8, 9, 10 are the complement of A. In the diagrammatic representation, here set A contains 1, 2, 3, 4, 5. The other than the A elements are 6, 7, 8, 9, 10 are in the universal set. So this is a complement. Now we will see the properties: commutative property, associative property and distributive property. I hope you remember these properties. If not, let's have a quick glance on this table. Let's verify these properties hold true with the sets. First, we will see the commutative property. Commutative property of union and intersection. Let's verify this with examples. Let's take an example of two sets. Set A is equal to 6, 7, 8 and set B which has the elements 4, 8 and 12. Now let's find out the union and the intersection of two sets obey this commutative property or not. A union B. The union of A and B is the elements from both A and B. Let's write the elements from A 6, 7, 8 and the elements from B 4, 8, 12. But here 8 repeats again, so we have to write one time. So 4, 12. Now the A union B is 6, 7, 8, 4 and 12. Now let's find B union A. In this, the elements of B are 4, 8 and 12. Now we have to write the elements from A. Here also the 8 repeats again. Without that, we will write 6, 7. Now observe the answers A union B and B union A. Both are having same elements. So A union B equal to B union A. So the commutative property holds true under union operation. Next we will see intersection. A intersection B. Here A intersection B is the common element between A and set B. Here we have the common element as 8. Now B intersection A. Here B intersection A also have the common element 8. So now the commutative property of intersection also holds true with the two sets. So A union B is equal to B union A, and A intersection B is equal to B intersection A. So union of sets and intersection of sets is commutative. Let's find out if associative property holds true with set operations. First, let's check with associative property with respect to union. Let's consider three sets. Set A consists of elements 6, 7, 8, and set B contains 4, 8 and 12, and C consists of 5 and 6. To check the associative property, we have to prove that A union bracket open B union C equal to bracket open A union B union C. First we are going to find B union C. 4, 8, 12, 5 and C. With this union I am going to find the union of A. Here I am going to include 7. 4, 8, 12, 5, 6, 7. Next I am going to find out in the bracket A union B union C. Here A union B is equal to 6, 7, 8, 4 and 12. A union B with union C gives 6, 7, 8, 4, 12 and 5. Now let's observe the answers. Both are equal. So therefore union of sets is associative. Let's see another example. This time we use Venn diagram. Let's take an example. Set A consists of 2, 3, 4, 8, and B consists of 4, 5, 6, and C consists of 7, 6, 8. Now we are going to find A union B. Here A union B, the common element is 4, so the combined set is A union B. Now meet element C with A union B. This is the Venn diagram for A union B union C. Now we find B union C. Here B union C, the common element is 6. Then meet the A with the B union C, you will get A union B union C. Observe both the diagram are same. Now we proved that associative property of union is true. Now we proved that associative property of union is true under set operation. Now we are going to prove that associative property of intersection is also true. For that, let's consider set A consists of 6, 7, 8, and B consists of elements 4, 8, 12, and C consists of elements 5, 6, 8. As per the associative property of intersection, we are going to prove A intersection in the bracket B intersection C close the bracket equal to in the bracket A union B close the bracket intersection C. First, the intersection of B and C is 8 because the only common element is 8 between these two sets. Again, the intersection of this set with A gives 8. Here also the common element is 8. Next, in the right hand side, A intersection B is also 8. Here also the common element is 8. Again, the intersection of A intersection B with intersection C gives 8 as a answer. So we prove that A intersection in the bracket B intersection C close the bracket is equal to in the bracket A intersection B close the bracket intersection C. We have proved that associative property of intersection is true. Now we are going to see this with the Venn diagram. Now let's take an example with the elements A is equal to 2, 4, 6, 8 and B with 1, 2, 4, 3 and C 4, 5, 6, 7. Now in this diagram, this is the intersection of A intersection B intersection C. Now first we find B intersection C. Then intersection of this set with A. If we observe, both the diagram resembles same. Now we arrived associative property of intersection is true under set operations. I hope you are all clear with the properties of sets. Now we look at some example from the textbook. Here in the example 1.19, if set A is equal to B, E, F, G and set B contains C, E, G, H, then verify the commutative property of union of sets and intersection of sets. Okay, now first we find the union of sets. Here A union B gives B, C, E, F, G, H. Here E and G repeats, so you have to write one time. Like that B union A also B, C, E, F, G, H. So from equation 1 and 2 we prove that A union B equal to B union A. Hence it is verified that union of sets is commutative. Now intersection of sets. A intersection B. Here the common element between A and B is E and G. So A intersection B is E and G. Then the intersection of B with A gives E and G. So both in the equation 3 and 4 we get A intersection B is equal to B intersection A. Hence it is verified that the intersection of sets is commutative. Next the example 1.20. If A is equal to minus 1 by 2, 0, 1 by 4, 3 by 4, 2 and B is equal to 0, 1 by 4, 3 by 4, 2 and 5 by 2 and C contains minus 1 by 2, 1 by 4, 1, 2 and 5 by 2. Then verify A intersection in the bracket B intersection C, complete the bracket, equal to in the bracket A intersection B, complete the bracket, intersection C. In the left hand side we have B intersection C in the bracket, which is equal to 1 by 4, 2, 5 by 2. Since B and C have the common element as 1 by 4, 2 and 5 by 2. Next, the intersection of this set with A. Here the common element is 1 by 4 and 2. So the A intersection in the bracket B intersection C is equal to 1 by 4 and 2. Then the right hand side. The right hand side we have A intersection B. The intersection of A and B gives the common element between the sets A and B. Here the common element is 1 by 4, 3 by 4, 2 and 0. So the A intersection B gives 0, 1 by 4, 3 by 4 and 2. Then the intersection of this set with the C. Here the common element between this is 1 by 4 and 2. Hence from the equation 1 and 2 we verified that A intersection B intersection C is equal to A intersection B intersection C. Next we see some of the problems in the exercise 1.4. Here the first sum is if P is equal to set contains 1, 2, 5, 7, 9 and Q is equal to 2, 3, 5, 9, 11 and R contains 3, 4, 5, 7, 9 and S is equal to 2, 3, 4, 5 and 8. Then find P union Q union R, second P intersection Q intersection S and Q intersection S intersection R. To find the first sum, first you have to find the P union Q which is inside the bracket. For that you have to write all the elements from P and Q. That is 1, 2, 3, 5, 7, 9 and 11. Then P union Q union R which is equal to 1, 2, 3, 4, 5, 7, 9 and 11. Okay, for the second sum, first you have to find P intersection Q. Here the common element between P and Q is 2, 5 and 9. Then the intersection of this set with S. Here the common element is 2 and 5. In the third sum, first you have to find Q intersection S. Here the common element between Q and S is 2, 3 and 5. Then Q intersection S with intersection R. Here the common element is 3 and 5. Next we will do the second sum from the exercise 1.4. Here test for the commutative property of union and intersection of the sets. Set P is equal to X such that X is a real number between 2 and 7 and Q is equal to X such that X is an irrational number between 2 and 7. Here Q is an irrational number and P is a real number. So Q is a subset of P. So P union Q is equal to P, and Q union P is also P, because in a union we have to write the bigger set. So from this equation 1 and 2 we prove that commutative property of union of sets is true. Next, for the intersection of sets, you have to find P intersection Q. Here P intersection Q is equal to Q, and Q intersection P is also Q. So from the equation 3 and 4 we prove that commutative property of intersection of set is also true. With this we will wind up the class. I hope you all understand the concepts and practice the sums very well. If you have any doubt, contact me directly. Thank you children. Enjoy the day.